Imagine, you're opening your window in the morning to see the view outside of your house. The view you see is so beautiful, but as time goes by, you get sweaty, your room gets brighter, and eventually your house gets hotter. And at some point, you just can't stand it. You try to use the curtains to make your house less brighter, but then it gets too dark. You tried to use blinds, but it doesn't seem to work that much. So, what choice do you have left? Let me introduce to you the Ardu-Electrochromic film device, my final year project designed for making your control of the brightness inside your house a whole lot easier.
Assalamualaikum warahmatullahi wabarakatuh to the FYP coordinator, Dr. Athirah Binti, my supervisor, Dr. Athirah Binti Taib, and you who is watching this video. Today, I am going to present to you what I call the thesis presentation. So, without further ado, let's start with my first slide.
Assalamualaikum warahmatullahi wabarakatuh. Hi, my name is Anas Akasyah bin Abdul. My matrix number is 1.70276 and my supervisor is Dr. Athirah Binti Taib. For my final project, I've conducted a project called the Ardu-Electrochromic film for home safety purpose.
So, let's start with the first topic, which is the background of my project.
I will explain briefly about three subtopics, which are smart materials, electrochromic film, and the glass industry. So what are smart materials? Smart materials sense and react to environmental changes such as mechanical, chemical, electrical, or magnetic signals. They consist of structures that give information about their environment, monitoring device crucial in engineering, optics, and medical technology. Electrochromic are one of the properties of smart materials. So what are electrochromic materials? Electrochromic materials change the optical properties when a voltage is applied across it. They are reversible. Simply to say, when there is electric, the material changes. They are made from polymer dispersed liquid crystal, which are nano-sized materials. In 2014, a reversible electrochemical mirror was developed by South Korean scientists that is possible to be applied in smart windows. These pictures show the transition of the electrochromic mirror from a transparent state to a reflective state.
It sounds interesting, right? So let me show you a real video of an electrochromic film changes its properties from a transparent state into an opaque state. So now we're done with the video, so let's continue.
The next subtopic is the glass industry. When we talk about mirrors, we will automatically talk about glass. So glass is one of the famous and used materials in the world. Ho Sai-Woo, chairman of Malaysia Glass Association, said that there is a 3 billion turnover for glass manufacturing and processing. Meanwhile, Gan Chi-Seong, chairman of Singapore Glass Association, said that countries invest $30 billion in the construction environment. Here are some of the uses of glass in our daily life. The uses of glass ranges from breaking glass, glass spectacles, to greenhouses, houses, buildings, and skyscrapers.
Now we're done with the background of my project. As we know, every answer needs a question. Every project needs a problem. So what are the problems that my project is going to solve? I will explain it in the problem statement.
Here are the problems that I found that led me to the development of my project. Firstly, global warming increases the amount of ultraviolet light entering the atmosphere. Also, greenhouse effect increases the temperature of the Earth. As a result, excessive exposure to ultraviolet radiation causes health problems such as skin cancer, sunburn, accelerated skin aging, and eye cataracts. Also, exposure to sunlight increases the temperature of the house. In houses, normal glass is not efficient in keeping privacy and safety of people. Also, normal glass need curtains which increase the construction cost of buildings for architects.
From all those problems, I found 3 objectives that I need to accomplish after creating my projects. What are those objectives? Let's find out.
From the problem statements that I stated just now, there are 3 main objectives that I want to achieve in the development of my project. Firstly, I want to develop an Arduino-based system powered by a solar source. Secondly, I want to develop an electrochromic film device that is controlled by Arduino. And my last objective is I want to evaluate the efficiency of the Ardu-Electrochromic film device.
So those are the 3 objectives that I want to accomplish after creating my project. So let's continue with the scope of my project.
For the scope of my study, I will be focusing mainly on the development of the electrochromic film attached with glass in houses. The electrochromic film will change its state from a transparent state to an opaque state and vice versa. The size of the electrochromic film that I will be using is the size of an A4 paper, which is 21 cm to 27 cm. Also, the conductivity of the electrochromic film will be measured using different number of voltages. Lastly, the Arduino that I will be using will be connected to a PIR sensor and UV sensor using solar panel as a power source. So, we're done with the scope of my project. Let's continue with the significance of my project. Here are the significance of my project. Firstly, my project will help people to monitor brightness inside their houses. Secondly, my project will also protect houses from excessive ultraviolet light. Thirdly, my project will prevent heat from entering houses, thus decrease the temperature inside the house. Also, my project will help maintain privacy and safety of people inside the house. Lastly, my project will help architects to lower their costs for house construction. My project is quite significant, isn't it? So let's continue with the literature review, where I listed all the literatures that I referred to in completing my thesis proposal. Here are some of the literatures that I referred before conducting my project. From these literatures, I want to find the solar UV index level and how to calculate them, the early history of electrochromic materials, basic structure and elements in electrochromic glass, detailed process in fabricating electrochromic glass, calculation on conductivity, resistivity, voltage, current and resistance, and also the detailed information of motion sensors to be used in my project. Those literatures are really important for me to complete my proposal. So the next chapter is the methodology part. In the methodology, I've listed all the components and materials that I needed to use to complete my project, the overall diagram of my project, and the workflow chart of the detailed process of my project. So, let's continue. Here are the materials that I will be using to develop my project. I will be using electrochromic film, which is the main component of my project. I will also use the PVC board and plasticine to make the prototype of my project. Next, the electrical components that I will be using to make my project is the Arduino Uno, which is a microcontroller, the Node MCU, which connects to the Arduino through Wi-Fi, the jumper wires, ultraviolet sensor which detects ultraviolet light, and also PIR motion sensor which detects movement. Next, I will be using solar panel as a power source, solar charge controller to control voltage from solar panel, pyranometer to measure solar radiation, multimeter to measure current and voltage, LCD display to display information, and thermocouple to measure temperature of surrounding. Also, I will be using two softwares for my project. Firstly, the Blink apps, which is an application in the smartphone, and also Arduino IDE, which is a software for the Arduino Uno. Here is the overall flow diagram of the system. I will start with the solar battery charger. So, the solar panel will be attached to the battery charger, and the solar panel detects light. If there is any light, the solar panel will produce electric voltage and transfers it to battery charger. The battery charger will charge the lithium-ion battery and transfer voltage to voltage booster. Voltage booster then converts the voltage to 5 volts and then transfer it to USB port. So, the USB port will transfer electrical voltage to any electrical circuit that is connecting to it. The next system is the security alarm, containing the PIR sensor and the buzzer. Firstly, the PIR sensor will be attached to the electrochromic film. Then, the PIR sensor will detect motion. If there is any motion, the PIR sensor will send signal to the Arduino Uno. Then, the Arduino Uno will receive signal and process data. The Arduino sends signal to the LCD display, and the LCD display will show notification to the user. The next system is the clap automation system. For the clap automation system, the sound sensor will be attached to the electrochromic film. The sound sensor will detect double clap sound. If there is any double clap sound, the sound sensor will send signal to Arduino Uno. Arduino Uno receives signal, process data and sends data to relay, and relay receives data and turns on or off the electrochromic film circuit. The electrochromic film will become transparent and opaque based on the turn on and off from the relay. So now, let's continue with the results and discussions. In my project, I did 3 experiments, which are efficiency of solar battery charger, range of detection of PIR sensor, and the efficiency of electrochromic film device. Firstly, for the efficiency of solar battery charger, I calculated the current and voltage using a multimeter. So now, here is the table of the efficiency of the solar battery charger. As you can see here, from the voltage and the current, I managed to calculate the power input and the power output. I measured the input voltage in 4 different weather conditions, which are night, morning, cloudy, and sunny, so that I can differentiate the efficiency of my solar battery charger in different weather conditions. So now, here is the graph of the efficiency of the solar battery charger. From the graph, we can see that the input voltage, where it is in the blue color, is increasing linearly, while the output voltage, colored in orange, is almost constant. So, it is proven that my solar battery charger can provide a constant amount of electricity to any circuit regardless in various weather conditions or time of the day. Next, I measured the range of detection of PIR sensor. I measured the range of detection of PIR sensor because I want to see how far the PIR sensor can sense an object in its surrounding. In this table, the PIR sensor managed to detect the motion of an object for about 1.6 meters. After 1.6 meters, the PIR sensor cannot sense any detection of motion anymore. Lastly is the efficiency of the electrochromic film device. Based on the table given here, the experiment was done from 1 p.m. until 4 p.m. for each 10 minutes. I measured the solar radiation when the condition of the electrochromic film is transparent and opaque. Then I will measure the difference so that I can calculate the efficiency of the electrochromic film device. As you can see at the final result, the average efficiency of the electrochromic film device is 61.95%. Now, from the graph, we can see that there is a clear difference in the solar radiation between the transparent state and the opaque state, which means that the electrochromic film device is doing a very excellent job in blocking the solar radiation and UV radiation from the sun.